Okay, so we'll start with problem number 10. The reason I'm not doing problem number 9 is, if you flip back to the previous page and look at B under factor, you will see something very, very similar. And then we have 11 also, which is kind of similar concept. So I'm just going to skip 9 and we'll start with 10. Okay, so I want you guys to think about 10. Again, you can hit pause and see if you can solve 10 by yourself. And then you can come back and look at what I have done. So if I look at this, again, I'm going to start working with my left hand side. So cosine square x, I'm going to leave it as cosine square x. And secant square x minus 1. I want to look at my Pythagorean ID statements and see if there's anything that looks like secant square x minus 1. So it does. Here we go. My third derivative, which is 1 plus tan square equals secant square, was rewritten as secant square x minus 1 equals to tan square. So I will replace this with tan square x, and my right hand side stays the same. And I used, from here to here, I used Pythagorean ID. And now, remember, you're going to continue working with this side. So cosine square x, we'll leave it as it is. But I can convert tan square, I can use quotient ID to rewrite tan square. So sine square x over cosine square x equals sine square x. And I used, basically from step 1 going to step 2, I used quotient ID. And cosine square gets cancelled, and step 3 I get my final answer. Sine square x equals sine square x. And from step 2 to step 3, all I did was to simplify, because I could cross out the cosine square, so just simplify, and I got my final answer. So that is number 10. Okay, number 11, I'm going to move on, and I'm moving along, and you can always hit pause at any time if you think I'm going too fast, and re-listen to what I'm doing. But I'm going to look at number 11. Number 11 looks a little more complex than the other things that we've done, because it's to the 4th power. I'm just going to rewrite it and see if we can do this again. Again, we've done something very similar. It was under like I said, it is similar to number 9, which was there in the previous page, something similar. But let's do it again. Secant here we go. Secant to the 4th power x minus tan 4th power x equals secant square x plus tan square x. And remember what we said, that we want to start with a more complicated side, and my left hand side is to the 4th power, so I will start with this. I hope we are all able to recognize that this is difference of square, because this is a perfect square, this is a perfect square. A square minus b square is a minus b, a plus b. So except a in this case is this, a is nothing but square root of a square, so square root of a square is secant square x, a square, a minus b. Can everybody recognize that? So this is a minus b and a plus b. So this was factored into this. Yes, can we all recognize that? This was factored into these two. A square minus b square, a minus b, a plus b. In this case, a square just happens to be secant to the 4th power. That means a will be secant square. And b square is tan to the 4th power, that means b will be tan to the 2nd power, right? And then you keep the right hand side as is. And what did I do? To go from here to here, I did factor. To go from the initial to step 1, I got to step 1 by, I'm sorry, you can't see. I got to step 1 by factoring. Yeah, we're all good. Now what do I do? Now I'm going to look at my Pythagorean ID and see if any of them can be replaced. And you have to keep your eye on your other side that you're not solving. So on the right hand side, secant square plus tan square, there is secant square plus tan square. So what can I do to this? So secant square minus tan square, I'm going to go ahead and look at my Pythagorean ID difference statement. And I do find my third derivative, which is 1 plus tan square equals secant square, which I got by dividing the first one by cosine. I rewrote this as secant square minus tan square equals to 1. So this secant square minus tan square equals to 1, secant square minus tan square equals to 1. So I will rewrite this as 1 multiplied by secant square x plus tan square x equals, keep the right hand side as is. And basically I went from this portion to just this by Pythagorean ID, right? We said secant square minus tan square equals 1 is Pythagorean ID. And then the last step is pretty obvious, step number 3. So this we got it in pretty soon, the steps, because 1 multiplied by anything is just secant square x plus tan square x equals secant square x plus tan square. Just simplify or multiply or whatever. In 3 steps I got my answer. I think the tricky thing in this was to be able to recognize that this is a square minus b square, so this is a minus b at a plus b. So we have to make sure our factoring of trig functions that our knowledge is good. Alright, so I'm going to remove this so that we can look at the next problem. So we got 11 done. Let's look at 12. So 12 is cosine square x over 1 minus sine x. So if I look at 12, I normally tell you to kind of simplify, but sometimes you have to use other strategies too. So there is 1 minus sine x. So I'm going to work with the left hand side. And there is 1 minus sine x in my denominator, and there is a square in my numerator. Can I simplify this and somehow get this? So I think a little bit and I see what can I replace cosine square with some form of sine, because my other side, what side is this? Right hand side contains only sine. So you kind of have to start thinking about strategies, right? So cosine square, if I look at my different Pythagorean ID, cosine square can be replaced with 1 minus sine square. So let's try that. Like I said, we have to try different things. Sometimes it will work, sometimes it won't work. So let's try to replace cosine square with 1 minus sine square. So I replace this with 1 minus sine square x over 1 minus sine x equals 1 plus sine x. And what do I notice here? That I do have everything as sine square. Okay, but what else? I need to somehow simplify this also. And then what I find is, okay, I didn't write the reasoning. So cosine square replaced to 1 minus sine square is Pythagorean ID. Then what I see is, I see that this is difference of square. Perfect square, perfect square. I can factor it. So I factor it by a square. 1 is a perfect square, sine square is a perfect square. So a minus b and a plus b over 1 minus sine x. So step 1, step 2, and this side stays the same. And I basically, going from step 1 to step 2, I did factor. And then, what do I notice here? On my left hand side, 1 minus sine x, 1 minus sine x cancels. And I have my answer, I have my proof. I just simplify. Okay, so hopefully we're all getting the hang of it. So like I said, we have to think of different strategies. So here you start by thinking, okay, I need everything as sine because there's only sine here. Let me see if I can start with that. Alright, okay, now let's look at the last one on this page, number 13. So here I see, again I'll start working with the left hand side because it looks a little more complex. I'll see if I can simplify that to sine square x. So looks like this I could use Pythagorean ID, right? Sine square x minus 1, we have seen it often. Sine square x minus 1 can be replaced with tan square x. So I replace this with tan square x. And I keep the secant square x for now. And my right hand side is sine square x. And basically from step 1 to step 2, I use Pythagorean ID. Okay, so now I notice that everything on my right hand side basically contains sine square. So I'm going to convert everything to sine and cosine here and see if something simplifies. So tan square x is basically sine square x over cosine square x over secant square x is basically 1 over cosine square x. Okay, so I know I did two things in the same step. Not the best thing to do, but you can do it. You can do it. I replace this with this and this with this. So what are the, I used two IDs. This to this was quotient ID. And this to this was reciprocal ID. So I used both in the same step. Some people will probably frown upon it, but I'm being lazy. And then now what do I do? Dividing fractions. You can do the whole sine square x over cosine square x. Dividing is the same as multiplying by the reciprocal. Right? Everybody good? So all I'm saying is simplify. Therefore, step 4 will give me my answer because I see I have only sine square x left here. Same simplify, and I got my proof of left hand side being equal to the right hand side. Alright, I hope you have learned how to do some of this, and you can do some of these independently now.